We're going to take a look at the Pythagorean Theorem, what it is, what it means, and what we use it for. The Pythagorean Theorem has everything to do with right triangles, and it says that a squared plus b squared equals c squared, where a and b are either of your two legs, it doesn't matter which one's which, and c is your hypotenuse. And remember, the hypotenuse is the longest side of your right triangle opposite of the right angle. So a squared plus b squared equals c squared. We can use this to solve for missing lengths of a right triangle. We can use it as a formula to plug some information in and solve for missing side lengths. So let's take a look at our first example here. Let's make up some information. Let's say I have to solve for x. I'm going to say x is my hypotenuse, and my two legs are 3 and 4. So first, it doesn't matter which one is A or B. 3 can be A, 3 can be B, 4 can be A, 4 can be B. It doesn't matter with the legs because we're adding. And remember, the property of addition is commutative, right? Addition it doesn't matter the order. You can add things however you want. The order doesn't matter. So I'm going to fill in my formula with A being 3. So I'm going to say 3 squared plus 4 squared equals x squared. In this case, my x is my c, my hypotenuse. Okay, let's go ahead and solve this as we would any normal formula. So I'm going to say, okay, 9 plus 16 equals x squared. Well, we know that 9 plus 16 is 25 equals x squared. And the last thing we need to figure out, okay, so if x squared is 25, then wouldn't x just be the square root of 25? So in this case, the square root of 25, we end up getting a perfect square here, which is nice. X equals 5. And I am done. Okay, so in this case, the hypotenuse here, x, would be 5. Let's try another example here. Let me erase my work here. I'm going to use the same triangle, but I'm going to put some different numbers there. It's obviously not going to be to scale, but that's okay. I don't really want to count on the picture too much. I'm going to get rid of my numbers here. I'm going to use the same triangle, but I'm going to change the numbers up a little bit. Let's say here we have a 10. We have an x here, and my hypotenuse is 26. Let's go ahead and solve this one. So again, we're going to fill everything into our formula that we know. Okay, I'm going to need a little bit more work for this one, so I'm going to start this off to the side here, and you'll see why this is going to be a little bit more involved. So I have 10 squared plus x squared. My two legs are 10 and x, so 10 squared plus x squared equals 26 squared. Okay, so the first step, I'm going to do the exact same as the last one. I'm going to go ahead and square the values that I do know. I have 10 squared is 100. Still have my x squared. And I'm also going to square the 26 and get 676. Okay, now just treat this like any normal equation. Okay, I got to get x by itself. That's the goal. So what I'm actually going to do, which is different from the first one that we did on this video, is I'm going to subtract 100. Okay, so I'm going to subtract this 100 here. That's going to give me x squared equals 576. Now again, x squared is equal to 576, so to figure out what x is, wouldn't I just take the square root of 576? The square root of 576 will end up getting me x equals 24, and I am done.